Welcome back for lecture 5. We'll continue our discussion of kinematics. All right. In the last lecture, just to review for a second, we spoke about the concept of speed, and we said it was a delta x over a delta t. Remember, delta is change in, x was a distance, so we said this was a change in distance divided by a change in time. And we said distance we're measuring in meters, time in seconds. Okay? And we said, well, the speed can also change. What do we call a change in speed with time? We call that acceleration. Once again, later we'll learn the difference between speed and velocity. For now, we'll use them interchangeably. Acceleration, A, we said was a change in speed over a change in time. The units then were meters per second divided by second. And so the units were meters per second squared. All right. And to illustrate what meters per second squared was, we used the acceleration due to gravity. On Earth, I mean, we're not on Pluto, right? We said g, the acceleration due to gravity, was really 9.8 meters per second squared, but we're going to use 10 meters per second squared, okay, for our problem, so we can do things in our head much easier. All right? So we're going to use the concept of acceleration and speed right now. Okay. Once again, let's go backwards. And if you remember, we said, all right, suppose we travel at 50 miles per hour and we travel for 10 hours, we go 500 miles, okay? That was our first kinematic or our first physics equation, but it's something you and I know. If you travel for 500 miles, you're in Buffalo. Good luck with that, all right? So we said the speed times the time was given to the equals the distance. This was our first equation. And then when we started talking about acceleration, look, if you travel 50 miles per hour, 10 hours, you go 500 miles. Great, great. Nobody travels at a constant speed. What do? You speed up, you slow down. All right, let's look at this. I'm going to talk units. I'm going to hand wave and not give you a fancy derivation, but try to explain in words, okay? An act of faith. Distance is going to be in meters. So on the left-hand side, we have meters. The right-hand side equation, what units must we have? Well, you have to have meters. You can only have things equal to each other if they have the same units, right? Apples and oranges, etc. V, remember, was meters per second. Time was in seconds. So when you cancel the seconds, you end up with meters. Fantastic. Meters per second times seconds gives meters. Everything's good. But what happens? What if we accelerate? Or decelerate? Okay? Again, I'm going to hand wave. I'm just going to not derive this, but talk and see if you understand. We'll just do some logic, okay? So let me give you a problem. Suppose we have a speed. Suppose I say V0. That's our initial speed. Suppose it's 40 meters per second. We okay? So in 3 seconds, it's clear I've gone 120 meters. Just multiply by 3. But what happens if I say this? Here's a problem. The initial speed of a car is 40 meters per second. Okay? 40 meters per second. Suppose the car now accelerates, ready for this? At a rate of 3 meters per second squared. So now you step on the accelerator and you go not at 9.8, we're going this way. We go at an acceleration of 3 meters per second squared. For how long? How long are you stepping on the accelerator? For, let's say, 5 seconds. Okay, so here's the deal. We're in the car, we're going at the initial speed of 40 meters per second. Now, for 5 seconds, we accelerate at a rate of 3 meters per second squared. So the question is, what is our new speed? Now I want everybody to listen, pay attention, okay? Because on an exam, if you get a problem like this, I want you to see the initial speed is 40. If we accelerate means we're going faster. So that means the final answer should be, better be, greater than 40 meters per second. So when you get an exam and there's two choices, one says 25 meters per second, the other one says 18 meters per second or something like that. The final answer cannot be less than 40 meters per second. Why? Because we're accelerating. It has to be greater. Now, watch this. 3 seconds, 3 meters per second squared for 5 seconds. Watch what I'm going to do. I'm going to write this, right? V final equals V that you start with plus, and I'll put a minus there, it could be either one, the acceleration times the time. What the heck, where did I get that? Let's look at units first. What's the units of V? You remember the units of speed? It's meters per second. What's the units of V0? This was I called V0 before. Again, has to be meters per second. Do you remember the units of acceleration? Right? It's meters per second squared. It's not the same as that. But when we multiply by time, which is seconds, 1 second goes out, second, so we're left with meters per second. Now, if we accelerate, what do you think we do? Do we take the plus or the minus? The answer is the plus. So V final is going to be equal to V initial plus, what did I have? Acceleration was 3 meters per second squared times 5 seconds. So it's V final is 40 meters per second plus 15 meters per second. So the answer is 55 meters per second. Just add. Okay? Suppose I ask the question, same problem, except I say, instead of accelerate, I say decelerates. Decelerates means you're going slower. So the final answer cannot be greater than 40. It has to be less than 40. So what do you think we do? Can you see? Yes. We use the same equation, except for now instead of adding, we're going to subtract. So we're going to have V final equals V0, the initial plus, I just said we're decelerating, minus AT. So it would be 40 meters per second minus 3 meters per second squared times 4 seconds. 5 seconds, sorry. So we get 40 meters per second, cancel out of seconds, minus 15 meters per second, and there our answer is 25. meters per second. That's our final speed. So if you accelerate, you add, and if you decelerate, you subtract. That's why here I put the plus or minus. Very, very simple. Okay? Not that hard. And again, the problems that we do, you can do this in your head. Just be aware that if you accelerate, the final answer must be greater, and if you decelerate, the answer must be smaller. Okay? Now, I want to go back to one other equation we've already had. And that was our first thing with distance and time. Distance equals the speed times the time. Remember? 50 miles per hour times 10 hours, okay? My question is, what happens if we accelerate? Here, I'm going to write V0. That's our initial speed. Once again, and I ask you to forgive me, I'm just going to talk us through it. I'm not going to derive it. This is not physics with calculus. Okay, I want to show you how to use this, and then I'll show you how we're going to use it. Okay? Again, let me look at units. Suppose we accelerate. So watch this. D is equal to, we agree this is meters. V0t, this is meters per second, and this is seconds. So the seconds go out, we're left with meters. Good, good. Meters equals meters. That's good. It's the way it's supposed to be. But now if we accelerate, just watch. Suppose I put an acceleration here. Okay? What's the units of acceleration? Oh, you should know this by now. Meters per second squared. Meters per second squared. But this is meters. This is meters. We cannot have meters per second squared adding to meters, and certainly will never be equal to meters. So how do we get rid of seconds squared? Got it? It's not that hard. If we multiply this by t squared, remember time is seconds. So when you square it, you get seconds squared. So that goes out with that. So initially we look, the distance is V0t plus AT squared. Wow. Remember what I said? I'm not going to derive this. I'm hand waving and talking about units. All right. Well, it turns out without derivation, there's a half here. Okay. We need a half. Half has no units. So we have meters, meters, and meters. So our equation, this other equation of kinematics, it looks bad. Oh boy, it looks crazy. But I'll show you how we're going to use it. Okay. Here's our equation. Distance is V0t plus 1/2 AT squared. I'm going to simplify this. You'll see what we'll do. Don't be afraid yet. Please, not yet. After the video, you can cry, but don't cry yet because your paper will get all wet and then you'll have to redo it. Okay? Meters per second times seconds, meters. Meters per second squared times second squared meters. Okay? Now remember, acceleration can be anything you want. However, if we drop something, what's the acceleration? Do you remember what the acceleration is always going to be? It's going to be g, the acceleration due to. So watch what I'm going. I'm going to ask a question. Here's the problem. Suppose an object is dropped. I'm going to underline the word dropped. You'll see why, because it means something mathematically. Suppose an object is dropped from the top of a building. Please do not do this with your sister. Suppose an object is dropped from the top of a building and hits the ground 4 seconds later. Okay, so I drop an object. 4 seconds later, I hear the thud. My question is, how high is the building? And what color is the building? No, don't worry about that now. How high is the building? Okay, so we're going to analyze this. We're going to talk about it and see if we can figure this out. Okay, first sip of water. Okay. We take an object and it's dropped. So let's analyze the word dropped. What does drop mean? Well, what is the initial speed if I drop something? Remember in the other video when I threw a water balloon down at 30 meters per second? My initial speed was 30 meters per second. Here, if I drop something, that tells me that V0 is equal to 0. Dropped mathematically means V0 equals 0. That's the initial speed. Fantastic. Now, when I drop something, V0 equals 0. What else does drop mean? Drop means it's going down. So it's falling. When something is falling, we know the acceleration. What's the acceleration? The acceleration is equal to g, 10 meters per second squared. The acceleration due to gravity. So what does our equation become? Our equation becomes V0t plus 1/2 at squared. So I want you to watch. Is equal to, we said V0 was 0 because it's dropped. It's good? 1/2 gt squared. Look at how easy this is. Now, we're going to play with this. What was the question? The question was, after 4 seconds, how high is the building? So, what is the value of t? T is 4. Okay? And what is t squared? It'll be 16. So I'm going to write this out. 1/2 10 meters per second squared times 4 seconds squared. Write that smaller so you know it's seconds. So it's equal to 1/2 times 10 times 16. Can everybody do that? All right? What's 1/2 of 16? 8. 8 times 10? 80. And this is going to be meters. The building is 80 meters high. You don't want to do that? Do this. Half of 10 is 5. 5 times 16 is 80. Well, half of 16, 8. 8 times 10. So an object dropped for 4 seconds. I put 4 in, 16, 160, divided by 2 is 80. So again, 4 squared is 16 times 10 is 160. Half of that is 80. Let's do a couple more. All dropping. I want you to watch. So we're going to drop an object. If we drop an object, we know d is 1/2 gt squared. So if t equals 6 seconds, then d is equal to what? Let's do it together. In our heads, forget calculators. T is 6. What's 6 squared? 6 squared is what? 36. G was 10. 10 times 36, 360. Half of 360, 180 meters. Again, 6 squared, 36. Times 10, 360. Divided by 2, 180. 8 seconds. So again, in your head, what's 8 squared? 64. Times 10, 640. Divided by 2, 320. It's really hard, right? Okay, what if T equals 5 seconds. Uh-oh, that looks hard. What's 5 squared? 25. Times 10, 250. Divided by 2, 125. Come on, come on, let's go, quick. In your head, we're drilling, let's go. How easy is this? Remember, when you take the T's exam, there's no time. You need to do things as quickly as possible. If you're putting this in your calculator, you're wasting valuable time. So try to do it in your head like we're doing, okay? All right, T equals 3 seconds. All right, so D is, what's 3 squared? 9 times 10, 90. Divided by 2, 45 meters. T equals 10 seconds. Ooh, ooh. 10 squared is what? 100 times 10 is 1,000. Divided by 2, 500 meters. One more because I'm getting really tired. Okay, suppose T is 3 seconds. Do we do that? No. 3 squared is what? 9. 10 times 9 is 90. Half of that, 45 meters. All right? Simple. You drop an object, you want to know how far it went? D equals 1/2 GT squared. Not a big deal. Okay? Now, let's turn the problem around. I want you to watch. We're doing some algebra, so I'll go slow. Again, I'm dropping an object. Okay? Suppose I tell you the distance and I want to know the time. So suppose I say an object is dropped from a building that's 400 meters high. How long did it take? So in this problem, I told you T and wanted to find D. Now I'm telling you D and want to find T. So we need to solve. Let's solve for T. So watch, D equals 1/2 GT squared. First thing I'll do, go slow, multiply both sides by 2. So I have 2D equals, the half goes out, GT squared. Now remember, we want to solve for T, time. So we have to get T all by itself. So if we divide both sides by G, the G goes out, divided by G. So what are we left with? We're left with T squared, I'll just put it on the left side, is equal to 2D over G. I don't want T squared. What do I want? I need T. Does everybody know about square roots? All right, let's talk for a minute about square roots. Let's review. So suppose I write the square root of 49, the square root of 25, the square root of 36, the square root of 81. All right, come on. What number times itself is 49? All right, 7. What is number times itself is 5. 6. 9. All right, we know how to do square roots. But suppose I say, don't get mad at me now, what's the square root of 43? So you take your calculator out and you work on the square root of 43. I don't care what the square root of 43 is. Here's what I care about. I know 6 squared is 36. I know 7 squared is 49. Yes? So the square root of 43 is somewhere between 6 and 7. All I care about is 6 point something. On my exams, multiple choice, I'm not going to give you 6.23, 6.17, 6.8. All you need to know is it's between 6 and 7, 6 point something. What's the square root of 57? I don't know. Well, 7 times 7 is 49. 8 times 8 is 64. So this is 7 point something. That's all I care about. Okay? So let's see. Let's see. Suppose I say, suppose an object is dropped. How long does it take to fall? Okay, you ready for this? Hey, 400 meters. Now watch, again, I do not want you to use your calculator. I want you to do this in your head. So we'll do a couple of these and we'll do it in our head and then we'll end this video so you can go have a drink of vodka or whatever makes you happy, okay? But let's look. 400 meters. So what am I telling you? I'm telling you the distance. What is 2 times 400? 800 divided by 10. So here, what we need is the square root of 800 divided by 10 is the square root of 80. What's the square root of 80? I don't know, but it's very, very, very close to 9, right? So it's probably something like 8.9, something like that. See that? Suppose it falls not 400 meters, 300 meters. So then I have 2d over g is equal to 600 divided by 10. Yes? Square root of 60. What's the square root of 60? Well, 8 times 8 is 64. 7 times 7 is 49. I don't know. It's 7 point something. That's all you need. Okay? Couple more. Let's go. An object falls, let's see. What did I say there? 300, 200 meters. Okay, so T is square root of 2 times 200 divided by 10. I'm being very careless with the units. Okay, so it's the square root of 400 divided by 10 is equal to the square root of 40. Okay, so that's about 6 point something. And the units will be seconds. Okay, all right, that's enough. See you next time.